Welcome to Ask and Learn.
All right, so here we're going to look at a object moving with a motion graph or position graph of f of t, and the position with time on the straight line is t cubed minus 8t squared plus 24t, where t is in seconds and s is in feet, and we're only interested for t greater than or equal to 0. And so what we're going to do is, based on this motion equation, we are going to answer a lot of questions. So let's go to it. Okay, first of all, we want to find v of t. And v of t is the derivative of our position graph. So we're going to go ahead and use power rule. We'll get 3t squared minus 16t plus 24 by power rule. And our units will be feet per second. So in feet per second. All right, so in part B, we want the velocity at 1 second. So that would be just what happens when you plug in 1 for t. So we'll go ahead and plug in 1. And that will give us 3 minus 16 plus 24, or 11 feet per second. So that is, I'll just box our answer so far. All right, let's take a look at part C. Part C is, we want to find out when our object comes to rest. So we need v of t, which is 3t squared minus 16t plus 24 to equal 0. And then the goal is to solve for t. So not necessarily easy to factor when you have that 3 in front. So let's go ahead and use quadratic formula. So quadratic formula says then t will be equal to minus b. Remember, we've got a, b, and c. So t is minus b, so 16, plus or minus square root of b squared, so minus 16 quantity squared, minus 4 times a times c. And that's all over 2a, so over 6. The trouble is that when we plug in to our calculator, we end up, I just kind of leave room here, we get 16 plus or minus, oh no, a minus 32. Square rooting a negative gives us an imaginary answer. Therefore, there are no zeros that are real. Therefore, v of t never goes to 0. Therefore, we can say the object never is at rest. Okay, so v of t never goes to 0. Okay, so that's good to know. All right, let's keep going up top. Next thing we need to know is when is the particle moving in the positive direction? Well, positive direction corresponds to velocity being positive. Well, I'll just say being positive, not greater, just positive. All right, since our velocity, we know the object is never at rest, we can just plug in any time, and if we get a positive value, it's always that way. So let's plug in t is 0 and it's positive. So since v of 0 is greater than 0 and we never stop, that means we're always going in the same direction. So therefore, we are always the object is always going in the positive direction. Okay, good to know. All right, let's keep going. We still have some more to go. All right, so part E, we need to find the total distance. And since we're always going in the same direction, the total distance is really just the change in our position. So position at, we're doing it over the first 6 seconds. So the difference between where we're at 6 seconds and where we're at 0 seconds. So at 6 seconds, we plug in 6 to our equation. So we're going to get 6 cubed minus 8 times 6 squared plus 24 times 6. And then all the terms have t in it. So s of 0 is 0. And when we plug that in our calculator, we end up with 72 feet. So we traveled 72 feet in those first 6 seconds. So this is first 6 seconds, first 6 seconds. Okay, excellent. All right, we can keep going. We have lots of parts. Okay, part F, we want to kind of sketch what's happening. And because we're always going in the same direction, we do start at 0. This is 0, and we do know that at we reach 72 feet at t equals 6 seconds. At t equals 0 seconds, we're at 0 feet. Okay, so we basically are just always moving in the positive direction and so on. So that's pretty easy graph there. All right, still 3 more to go. I might have to clear the screen. Let's see if I can write it super squishy. Okay, let's look at G. G is finding the acceleration and then plugging it in 1 second. So that's the next derivative. So if we do power rule on V, we'll end up with 6t minus 16. So if we want a of 1, that'll be 6 times 1 minus 16. So we get minus 10, but our units are feet per second squared. So minus 10 feet per second squared. Okay, so I'll probably might need to erase part of it. Let's see if I can at least do the best I can. I'm going to make a little spot for the remainder, and this is where, well, I think I'm actually going to have to erase. So I will erase what I have, or erase to make space because we still have 3 more parts. So I will erase after just a sec here. Okay, so I cleared the screen and then rewrote for us the position, velocity, and acceleration equations. Part H asks us to rough sketch of our position, velocity, and acceleration graph. So I did it rough, just so you can see the with time roughly the kind of shapes of each of these graphs. And then we've got still part I and part J. Part I says basically we have to find out, well, I and J will kind of do together. I is basically times when object is speeding up. And J is times when object is slowing down. Okay, so the rule for objects speeding up is when velocity and acceleration have the same sign. And slowing down is when velocity and acceleration have opposite signs. All right, so we already learned from previously that we have always a positive velocity. And you can see from the little graph in blue that velocity never hits 0 or goes negative, it stays positive. So since V is greater than 0, then for speeding up, we need acceleration to also be greater than 0. And on the opposite case for slowing down, since V is greater than 0, then acceleration has to be negative. So if we look at our graph of acceleration, you can see we're negative up until this point here, and then it switches to positive. So we just really need to know when A of t goes to 0. So since A of t equals 6t minus 16, we can set that equal to 0. We can add 16 to both sides and then divide by 6. So that's 16 over 6 seconds, or if I divide by 2, 8/3 seconds. So basically, when we're below 8/3 seconds, then acceleration is negative. So we, if we're less than 8/3 seconds, then we have a, we're slowing down. And I think we're only counting starting at 0. So this is slowing down. And after that, the acceleration is positive. So after that, we are speeding up. And I suppose I could probably just do it without the equal sign. So t greater than 8/3 second, we are speeding up. And I'll go ahead and I think this is good. So we have accomplished all the parts for our motion. Okay, have a wonderful day and I'll see you next time.